All right, so oxidation states. This is a very important thing to understand when it comes to oxidation reduction reactions and electrochemistry. Oxidation states or numbers are a bookkeeping device for electrons in electron transfer reactions. So oxidation reduction reactions. The charge of an element would have, or oxidation states or numbers are the charge an element would have if the bonding in the compound were 100% ionic. So if it lost or gained an electron, what would it be? Now, when it comes to assigning oxidation numbers, there are a couple of ways that you can do it, and a couple of ways that you can kind of visualize it. When we look at different species, over here in the left-hand side, this column, when we look at an element of something, so Fe, iron, listed as a solid, that would have an oxidation number of 0. Now, oxygen, O2, as a gas, that would also have an oxidation number of 0. A monatomic ion, well, sodium is +1, fluorine is -1. Oxygen outside of O2 is typically going to be -2. However, in the case of a peroxide, so hydrogen peroxide, H2O2, that's an instance where oxygen has a charge of -1, but typically it's -2. Hydrogen, when bound to any nonmetal, it's going to be +1. When hydrogen, however, is bound to a metal, then it's going to have a -1 charge. So for instance, MgH2, that would be -2. Or sorry, that would be -1, and there's 2 of them, so that's a total of -2, which is why Mg has a +2. Now, others, well, the sum of the oxidation numbers must add up to be 0 in a compound, or add up to that charge in a polyatomic ion. Now, a couple of examples here. I want you to assign the oxidation states for all of the atoms in the following compounds. CuCO3. So what you need to do is be able to recognize that CO3 is the carbonate ion, and CO3 has a charge of -2. And based on that being -2, then Cu has to be +2. So now what we're left with is, let's go ahead and list these out. Cu is +2. Now we need carbon and oxygen. Well, if the 1 carbon and 3 oxygens add up to be, well, -2, then effectively we've got a math equation that looks like this. Blank plus 3 times, well, -2, because that's our typical charge for oxygen, that is equal to -2. So we can rewrite this. I'm going to do some erasing. And I'm going to rewrite this as blank plus -6 equals -2. So what plus -6 equals -2? Well, that would be +4. So assign the oxidation states for all atoms in the following compounds. Oxygen here is going to be -2. All right. Now, next up, I'm going to do some more erasing. And CH4, we've got carbon and hydrogen. Well, if each hydrogen is rolling in with a +1 charge, because hydrogen is almost always +1 unless it's with a metal, and carbon is not a metal, that means that carbon has to be -4. Okay, so C and H is +1 and -4 respectively. All right, now this next one is a little bit more complicated, but there are some things that you can kind of deduce from it. NH4 has a +1 charge. Hydrogen has a +1 charge. So our math equation for this NH4 is blank plus 4 times +1. I'll do some more erasing. Four times +1 equals +1. This, another way of looking at it, is blank plus 4 equals +1. Well, that would be -3. Because if nitrogen, I'll write these species out over here on the left-hand side, nitrogen, hydrogen, Cr and oxygen. Nitrogen is going to be -3, hydrogen is +1. Now Cr and O, okay, so, well, what I know about this is it is +1. Therefore, this is -1. So Cr plus 4 times oxygen's charge, which is not 0. That was just my symbol for oxygen. 4 times what? Well, 4 times -2 equals -1. This -1 came from my overall charge of CrO4. Now I'm going to switch this out. Rather than Cr, and rather than it being 4 times -2, instead I'm going to say plus -8. What plus -8 equals -1? And the answer to that is +7. So Cr is +7, O is -2. All right, I hope that was helpful. This should be helpful for you for question number 1 of your homework, as well as where you need that information. Okay, have a good one.